my previous video, we discussed the mole concept, and we arrived at some numbers like the Avogadro's constant. And in order for us to understand the mole, we compared a mole to a dozen, and we discussed how Avogadro arrived at the Avogadro's constant. From the video, we can actually conclude that 1 mole of any substance contains this number of particles. The mass of 1 mole of any substance, that's a number of this particle of any substance, is the mass of this number is called the molar mass of the substance. And if that substance is a gas, Avogadro also discovered that at XTP, that 1 mole of the gas, which is this number of particles of the gas, will occupy a volume of 22.4 dm cube. So from this concept, we can actually solve different questions that have to do with the mole concept. Now let us look at some of these questions. We'll solve some of these questions in this video and solve the others in the other video. Now check these out. What mass of nitrogen gas will occupy a volume of 1.12 dm cube? Now the way we can solve this is easy. It can easily be solved by comparing the bottom units. The first unit here is dm cube, and that is the variable there is volume. Here we are comparing volume to the mass. The relationship between volume and mass from this linear expression is just molar mass to gaseous molar volume at STP. Therefore, we can solve this question simply by just comparing, saying we can just solve it by simply saying that 1 mole of the substance, any substance, equals 1 molar mass normal, 1 molar mass, and that being a gas that occupies a volume of 22.4 dm cube, and the substance here is nitrogen gas, and 1 mole of nitrogen gas should be N2. The molar mass of N2, because we know N to be 14, N2 should be 2 times 14, which is simply 28 grams. So it means 28 grams of nitrogen gas should occupy a volume of 22.4 dm cube at STP, just like Avogadro discovered. So using this value, we would therefore compare, according to the question, we'll compare this to what we have in the question. So if 1 molar mass is 22.4 dm cube, then what mass should equal this number here? Therefore, we can easily say that if this equals this, then X, which is the unknown number now, should equal a volume of 1.12 dm cube. Now cross multiplying, our X will simply equal 1.12 dm cube times 28 grams divided by 22.4 dm cube. So from this we can say dm cube will cancel dm cube, and that should give me 1.4 grams. Yeah, now 1.4 grams of this gas should definitely occupy that volume of the volume of 1.12 dm cube. In an alternative way, in an alternative manner, we can simply use the equation which simply says that volume over the GMV, that's the gaseous molar volume at STP, equals the mole, and mole is the mass, the given mass over the molar mass. Now from here, because we're looking for the mass, we can simply say that the mass equals the volume over GMV, the gaseous molar volume, times the molar mass. And doing this, the mass becomes, the volume given is 1.12 dm cube over the GMV, gaseous molar volume at STP, is 22.4 dm cube times molar mass, which is 28 grams per mole. So the dm cube will cancel dm cube, and actually this will give us the same answer, which is 1.4 grams of nitrogen. Now, having discussed this, we will quickly solve the other question. The other question says, what is the mass of an atom of hydrogen? Now, the relationship between mass and number of atoms is molar mass equal number of particles. So let's quickly solve that. In order to do that, we would just say that molar mass equals 6.02 times 10. 6.02 times 10 raised to the power 23. Now, knowing fully well that the molar mass of hydrogen H is 1 gram per mole, one atom of hydrogen weighs 1 gram. Therefore, 1 mole of hydrogen gas, the molar mass of hydrogen atom is 1 gram. Therefore, 1 gram contains 6.02 times 0.02 times 10 raised to the power 23 hydrogen atoms. So therefore, if this contains this, then what will be the mass of one atom, of one each? So therefore, X here will cross multiply. X becomes 1 gram times 1 each. 1 gram times 1 each, that's 1 hydrogen atom, everything over 6.02 times 10 raised to the power 23. Now this should give us a total of 1.66, approximately 1.66 times 10 raised to power minus 24 grams. Why? Hydrogen will cancel hydrogen, so we'll be left with grams. So this is our answer. All right, I believe I've been able to help you to an extent. This video, I hope this video helps. So in my next video, we'll solve the other questions. So don't forget to like, share, and subscribe. See you in my next video.